Happy Thursday, folks. We're going to be taking today to pull together everything that we've done up to this point. We're going to use the graphical method one more time to illustrate why adding by the component method works. So I'm going to have us start out by, first of all, actually drawing one more vector and one more vector addition. So I'm going to have us do this. And mine's going to be a little rough because I can't really use a protractor on my iPad. So it's not going to be exactly as pretty as yours should be. But I'm going to draw a 50 kilometer vector, 20 degrees northeast, and a 40. So this one should be a little bit shorter. You make sure you make it so. I'm not sure I can with this. But yours is 40 kilometers, and this is 65 degrees. Now, if I'm adding it by the graphical method, then what's going to happen is I'm going to have my, and this is little letter A in your notes. This is little letter B, where I'm actually adding it by the graphical method. So I have vector A at 20 degrees. That might be a little bit steep for 20. In fact, it is, and I want to be as true to this as I can be. So we have vector A at 20 degrees. I probably did the same thing. And then I'm going to attach vector B to it at 65 degrees, but it's not going to be quite as long. So that, it looks pretty close. Yours can be precise because you actually have the tools in front of you to do that. So my resultant is going to look like this. So that's the graphical method. Now if I put this into a coordinate system, it would look like this. There's a reason why I'm doing that. Remember, this is my 65-degree angle right here and my 20-degree angle right there. Keep this in mind, and I'm going to overlay this on an XY axis that actually is going to show me the whole thing put together. So I want you to draw under letter C. If I break it down by the component methods, this is what I'm going to end up getting. I'm going to draw a nice big XY axis, but I'm going to leave a little room at the bottom. And I'm going to draw my two vectors, and I'm going to try to draw them with two different colors. So the first one I'm going to make light blue. And this is the one that's 50. And again, I'd like you to be as accurate with it as you can be. 50 at 20 degrees. And then my next one is going to be, and I'm going to make this one green. So this one is 40 at 65 degrees. So yeah, that's kind of messy. I'm sorry. Let's try that again. So 40 at 65 degrees. That looks not bad. It's not the prettiest line I've ever drawn, but it's not bad. And then my resultant is going to be, I'm going to make that in red. And remember, the resultant is just the dotted line. You can make it a solid line, I don't really care, that connects the ends, and the resultant is going in the northeast direction. Now, I want to talk to you about the components that we've dealt with before. So for this, if I drop my perpendicular, this becomes the x component of this triangle. So I'm going to call this, if this is vector A, then I'm going to call this A sub x, or the x component of my triangle. I have to check my timer here for a second, folks. And if I drop this one down, this becomes, and this is vector B, this becomes the x component of my B vector. I want you to notice that this is really nothing more than a line. That x-axis is a number line, if you want to look at it that way. So I actually can add those two pieces because it's just adding two segments on a number line. So that's going to become important in a little bit. Now I'm going to go back and I'm going to do the same thing for x, or for my y components. So for my y component, if I pull this over, this much is the y component of my A vector, and this is the y component of my B vector. So it's going to be B sub y. I didn't need to do that on the side like that. Now again, if I'm just looking at this as I can add these pieces up, that's going to come in handy, because now I'm going to look at my resultant. If I look at my resultant and I make my resultant a right triangle, if I pull it down, if this is my vector, which is the resultant vector, this whole thing is r sub x. But I have a way of finding r sub x, because isn't r sub x really nothing more than a sub x plus b sub x? So if I know a sub x, you know how to find components of a vector, and I know b sub x, then I just add them up to get r sub x. The same thing is going to be true on the y-axis. So if I want to find the y component of my right triangle, the big right triangle, it's going to be this. So this is going to be r sub y. But notice r sub y is nothing more than b sub y plus a sub y. So if I know b sub y, which by the way, I use the components of a vector to find that, and I know a sub y, then I ought to be able to find r sub y. So the trick with this is going to be, can I find the components of the vectors? If I find both of the x components and add them up, that's going to give me the x component of the x leg of my right triangle. If I know one leg of the right triangle and I know the other leg of the right triangle, can I find the magnitude of the resultant? A squared plus b squared equals c squared, my resultant. The trick with this is breaking it down into the component pieces here and here so that I can add them up here and here to get my leg of the right triangle. I know this component and this component, add them up to get this leg of my right triangle, and then it's just a squared plus b squared equals c squared. Now, for now, I'm gonna stop the video here so that we have time to work through that. Actually, I'm going to go on to something else first. On the rest of it, I want to talk through what this actually looks like for equations. So we've established little Roman numeral 1. I'm right here in the notes, little Roman numeral 1. I already know that a squared plus b squared equals c squared. So if I go back to this, then really what I'm saying is what I'm really saying is r sub x squared plus r sub y squared is going to give me r squared. So please write that in as an equation. Or what I really want is r. I don't really want r sub x, or I don't want r squared, I want r. So I'm going to take the square root of both sides so that my actual equation is going to be r is equal to r sub x squared plus r sub y squared. So that's going to be my working equation to find the resultant. But the resultant is magnitude in unit, but it's also angle, so I have to find my angle, and it's also direction. We'll talk about the direction in a minute. So to find the angle, if the tangent of the angle, and let's go back to my drawing, if I know r sub x and I know r sub y and I'm looking for theta, then I have my opposite that I know and my adjacent that I know. And you could use other formulas as well, but we're all just going to use the tangent formula. So to find this, then what I'm going to do is I am going to use the formula. Theta is equal to the inverse tangent. Well, we'll jump up one. The tangent of theta is opposite over adjacent. So the opposite side on my drawing before is r sub y. The adjacent side is r sub x. And whether they're positive or negative, it doesn't matter. We're just going to assume absolute value. Everything is positive. But I don't want to know the tangent of theta. I want to know theta. So to get theta all alone, I move it over by doing the inverse tangent, and that's an actual function on your calculator. It is the second function of your, it's the second function of your tangent button. So when I plug it in, it's just going to be the inverse function of r sub y divided by r sub x. So let's look at the problem that I actually gave you where we had, and this is little Roman numeral v, where we actually had numbers to it. So the x component is just the vector cosine of theta, and what I gave you was 50 cosine of 20, plus my other vector, the magnitude was 40, and theta was 65, but because it's x, I'm going to use cosine. When I do both of these and add them up, and they're all positive because they're all in the first quadrant, you get 64 kilometers. R sub y is equal to a sub y plus b sub y. We showed you in the picture before, that's what made that whole leg. But a sub y is nothing more than finding the y component of your vector a. Y component is just the vector sine theta, you find that, plus vector b sine of theta for b. You do the math and you end up with 53 kilograms. Now I have found r sub y up here in Roman numeral 2 and r sub x and r sub y. So I plug it into the equation, little Roman numeral 7, and what I end up getting for that equation is 64 squared plus 53 squared is equal to 83 kilometers. So this is my magnitude, this is my unit. When I put it into my theta equation, I'm finding the inverse tangent of y, which is 53, we found that right here, all over x, which is 64, we found it right here. You do the math and you end up with 40 degrees. It's northeast because both of these are positive. And if they're both positive, the only place they can both be positive